Welcome to Inside Builder channel, large language model automators, Python experts, and my dear friends. Discussion on model backends, GPTQ 4-bit quantization, compressing the model after pre-training. So what is the challenge that has been solved, and what are we going to discuss in this particular video? Reducing the size of the model and increasing the speed of the inference. Both of these things have been achieved using GPTQ. What is GPTQ? So GPTQ is basically generation pre-trained quantization process. So after the text generation models have been pre-trained, the models are quantized. The quantization is a process of reducing the model parameter size. So the model parameter size in the regular process is FP32 or TF32. So they are 32 bits wide or 32 bits big. That means each parameter is going to be 4 byte. The quantization process, if you have been following up with the various processes that has been followed till now, the till GPTQ, before GPTQ, there was bits and bytes, accelerate, etc. They were able to achieve 8-bit quantization. So even with bits and bytes, there is a way to achieve 4-bit quantization, and there is something called as normal float 4-bit quantization. That is also was achieved with bits and bytes. But then came GPTQ algorithm, and this is state-of-the-art quantization algorithm that is available right now. And we are going to discuss about that in detail. Why have I put the Oobabooga text generation UI and all this here is because Oobabooga text generation UI provides a unified way of understanding what is available in the market. So let us go back to the browser for a second, and if you give me a moment. This is the So here you see that I have already opened up the text generation UI that has been provided by Oobabooga, and there are lots of settings. I'm not going to talk about the UI, or I'm not going to talk about Oobabooga, the product or the service for that matter. What I am here going to talk about is the model loaders. So if you come to model loaders, you can see there are lots of model loader available here. And auto GPTQ, GPTQ for llama, xllama, xllama-hf. So there are lots of options available in the model loader. So what are these model loaders about? That is one thing. And then if you go to the parameters, so these parameters you have already understood. If you are working with large language models, if you are trying to automate it, then you must have understood all these concepts by now. The idea of taking this particular interface and trying to understand this interface will help you to actually develop your own applications. So Oobabooga has done a wonderful job of bringing all these multiple kind of programs and libraries in one place, and he has created a wonderful interface, and this entire interface runs on Gradio. So if you guys are new to Gradio, I'll be taking a separate video on that. But this entire interface is not done using any of the front end and back end kind of stuff. So it is all done together with Gradio. That is also a Hugging Face library, which you can learn about in the Hugging Face hub. We are going to primarily discuss on these model loaders and what are these model loaders and what are the differences. Why are we doing this? The reason is, as we go forward, as I already told, that one of the reasons is that you can create your own products, because this particular UI that you see is part of Oobabooga's text generation UI. But what if you want to take part of this text generation UI and you want to implement it in your product? That is where we have to understand what is going on, right? You you can always take the code and cut and copy paste it, but what if the code doesn't work, and how are you going to debug it, and how are you going to find the relations between various libraries that Oobabooga introduces in his one-click installers? So if you go to this particular link, so that you see at the top, so this is the first link I want you guys, if you are not started working on these things, I would like you guys to go to this particular link, clone this GitHub repo and install it. if you guys are not having the system or the machine that can capable of install PyTorch or not having sufficient RAM, then I would suggest that you can use this same installer inside AWS, GCP or Azure instances, that is virtual instances, and then you can create a kind of you can create the link, or you can connect to the server inside the instance, and then you can use it from the local environment. So what I mean to say is, let me go back to the browser. So this particular UI that you are seeing, this is not hosted in the local machine that I am making this video. So this is hosted inside the Google GCP server, and from that server I am connecting using this particular link. So in Gradio there is an option where you can ask for a public link. So you see, this is a public link, and this link will not be active for long, so it will be given a stipulated amount of time. So it's basically an ngrok link that has been provided for a stipulated amount of 2 hours or 3 hours. I think it is for 3 hours. Just a minute, let me check that out. I think I can check it out. Oh yeah, it is for 72 hours. So it's for 3 days actually, not 3 hours. Okay, now this is something you guys can try, and most of you might think that, okay, Kamal, this is too much complicated for me to try. Actually, it's not. So once you go to the link that I'm talking about, once you use this particular link, you will be able to just follow whatever the instructions has been provided in this repo, and you will be able to install it. It's very simple. And this particular video will actually walk you through the various models and the kind of a background that you need to understand. Okay, so quantization is a process of reducing the size of the model by converting the parameter bit type. Okay, all the language models are made of parameters. These parameters are nothing but actual numbers or floats, that is decimal numbers in layman terms, and these decimal numbers or the floats have a precision. Precision is meaning how many decimal points or how many numbers can be there after the dot on the decimal point. So in case of TF32 and FP32, it is having a large number of precision. So I am not going to discuss about the precision. I have discussed about these things in the earlier video. You can take a look at that in my playlist where I talk about this in detail. So if you go to this particular playlist, I talk about 8-bit quantization and the details behind the quantization in this particular video. So take a look at that. You will understand what is going on in the quantization with respect to 8-bit. Right. In this video, what we are discussing is that how 4-bit quantization is achieved, and apart from that, how it is getting implemented. I am not even going to talk to you about how it is achieved. It's actually does not matter for people who are going to use it. We have to know a bit of a background. So if something is not working, then you will know what needs to be done in order to make it work. 4-bit quantization or 8-bit quantization provides 95% accuracy when compared to the actual model. Okay, and so the speed up in case of 4-bit is almost 50% speed up, and in case of 8-bit is 40% speed up. So all these things I'll be discussing with data in a bit of a time. Here you see these are the various GPTQ implementation. So you can actually take a look at these implementations. So I'll be going into them in detail, and apart from that, you need to also be aware of something called as Triton. So Triton is a massively parallel programming language. It is kind of an alternate to CUDA programming language. So Triton is based on something called as program being blocked instead of the thread. So okay. All you need to understand is that there is a different kind of a programming language which is used for writing the GPTQ Python programs. You don't need to really understand what is actually getting written inside it. Most of the time we actually don't need to understand, but what you need to understand is that Triton is a programming language, and the Python code that is written in Triton is faster compared to CUDA. And it is more useful when you are going to especially work with neural networks and you are going to deploy it in GPU. So Triton is specifically created for such a application, for neural network application. And so you see there is an implementation by FP Gaminer called GPTQ Triton. So the GPTQ algorithm using Triton language has been implemented. And IST DAS lab. So this is the lab which actually, okay, I'll be going into the background of this. So you can take a look at these links. There is a lot of discussion which I used personally to understand about all this repos and how it is all coming together. So these are the discussions I used personally. So before GPTQ, there were bits and bytes, there is accelerate and PFT. I discuss about these libraries in this particular video, and this particular video is little bit longer. I bring in all the concepts, accelerate, PFT, and bits and bytes in a single video. The reason is I wanted it to be kind of a complete package instead of actually segregating it, because as you see in large language models, most of the concepts are linked together. If you separate it, it becomes very difficult to understand what is going on. And yeah, even if you bring it together, it becomes a little tough, but at least you can walk through it a couple of times and you will be able to understand. That is the reason why I'm trying to club things together rather than segregate it or separate it. Okay, so that is that's the discussion that I want to have in this particular slide. Let me go to the next. So this is the GPTQ evolution. So it all started with IST Austria and ETH Zurich teams. They came up with GPTQ algorithm, and this particular slide will be this particular presentation will be shared with you guys over the GitHub repo, so you can take a look at all these things at your comfort. And all this will have its own links. You can click and go to the respective GitHub repos or to the documentation. So this is the paper that was written by these guys, IST Austria and ETH Zurich team, and they introduced GPTQ in ICLR 2023 paper. Then what happened is, so based on this GPTQ implementation, another 3 guys came out and they created implementation, and that is GPTQ for Llama, XLlama, AutoGPTQ. And from GPTQ for Llama, another one implementation was created called GPTQ Triton. So you see, this is an overall picture of what is going on in the large language model arena right now. So this is one of the important topics, and it becomes extremely confusing when you see all the updates coming as bits and pieces. So I felt, okay, let us join all these things together, so it will be easier for you guys to understand what is going on, and also you will understand a little bit better in the next slide. So GPTQ can quantize GPT models with 175 billion parameters, reducing the bit width to 3 or 4 bits, and you can execute a 175 billion parameter model inside a single GPU for generative inference. And this is one of the important breakthroughs that I want you guys to understand. So if someone asks you what is the significance of GPTQ, this is the significance. That using GPTQ, you can reduce you can compress a big model to such an extent that it can fit inside a single GPU. And this single GPU can be 40 GB GPU or 80 GB, 800 GPU, but still it is a single GPU. So that is one of the important aspects that you have to remember. And all this team are working using their knowledge, and they are sharing it. And all these are available as open source, and you can access it with using either Python or GitHub repo, and whichever method is easier for you. And all these things are actually linked together by Oobabooga's text-generation-webui. So this is how everything is coming together. Apart from this, there is something that I want you guys to understand. Okay, so here is a brief about what GPTQ does. So I am telling the various points that has been shared by this team. So they have actually shared this, and I've just placed it here. Okay, the point is, you don't need to actually know what all that means. Model size is reduced. This is what you have to understand. And once the model size is reduced, what you're going to get, you are able to put the model inside the GPU, and you're going to do the inference, and it is going to speed up also. How fast? That's the next question you are going to ask. So here are the benchmarks that has been shared by the respective team members by themselves. So this is GPTQ Triton performance, and you see here that the Llama 7 billion model, when it is in FP16 precision, it is 17 GB, almost 18 GB. You cannot fit it in one T4 GPU. So you need two T4 GPUs. That is NVIDIA T4s. Or you need one P124 GB GPU. However, once you place it through GPTQ CUDA or Triton, you can actually reduce the size to almost 8 or 6 GB. That is a huge change, right? From 18 GB, they are reducing it to 6 GB. So you see the difference. That is what I was talking about. And you can actually load this model inside a Google Colab GPU that is provided for free. That is something powerful that I want you guys to really start using these things. And most important point is that after loading this, you will have a huge benefit in huge speed up in the inference. So instead of actually waiting for a minute or 2 minutes to get one single word or one single token, now the token generation is in seconds. So that is what you see here. And when it comes to there are other improvements also. So GPTQ for Llama. So this particular okay, so I don't know how to pronounce this particular name. Let me say QAP 200 had created a implementation of GPTQ for Llama especially, and this RTN, this is round to nearest. So I did not know what is RTN, so I had to do a search. So RTN means round to nearest, and you see that here is a comparison. So here the memory reduction is from 13 GB, almost 14 GB. He has reduced it to 4.7 in case of GPTQ, and GPTQ in case of this is with respect to 3-bit quantization. They have reduced it to 3.8 GB, and you can see the checkpoint sizes also. So in case of so basically checkpoint size is the size of the model itself, but in this case we can see visibly that the model checkpoint size itself has reduced. Next comes Auto GPTQ, that is created by Panchi Wei. This Auto GPTQ, he has given the comparison, and you can see the GPT-j 6 billion model can be placed inside RTX 3060 12 GB, and we see that it is going out of memory. Okay, but if you are going to do it with GPTQ int4, that is 4-bit, then you are able to get the inference in 29.55. So this is something, something that is really powerful. All you need is 12 GB of RAM, and you are able to place it inside. And also you can do a beam search of 4 beam search. So basically what a beam search is, or what a greedy search is, whenever there is a generation of tokens from the model, there is one more decoding process that is done by the tokenizers that we use, and it selects the most probable word or token. So that is called as beam search, and here we can use up to 4 beams. So this is a huge benefit when you are using higher beam numbers. Also you see various other comparisons, and all these comparisons are based on less number of GPUs. So I believe that you had got a clarity on what are the various types of models that is available, what are the various types of methods or the backends that you can use for loading all these models, working with the various open source models and converting it to GPTQ. So you might actually think, Kamal, what these repositories or what these people have done, how to use it. So what happens is, if you click on any of these links, it will take you to the respective respective repositories. And if, for an example, here it's GPTQ for Llama repository, and here they actually explain to you what exactly needs to be done. So if you scroll down, they show you a lot of information, the comparison, and then they provide you the necessary steps you need to take to load the models. And most of the time they also tell they have already done the conversion, so you don't need to do the conversion of the regular model, that is FP16 model, to GPTQ version. So like this FP16 model is regularly available in Hugging Face Hub. You don't need to convert it to GPTQ manually. So this is a way of understanding all these things and going deep into it. So you can let me go back to the PDF. So you can use this PDF and you can explore it. If you click on Triton, for that matter, if you go to the browser again, so it will open the Triton language documentation. So you can understand a little more detail about what exactly Triton is about. The reason why I'm actually sharing all these things is when you are working with the text generation UI that is created by Oobabooga, you might have a good deal of experience, or you might be intermediate experience in Python and programming, and you might want to create a new kind of application, or create an embedding in your application. Embedding in the sense you want to create a part of the application which uses these models or these algorithms. Then it will be better for you to understand how these things are implemented by the individual repositories or individual developers, and then you can actually use it in your applications. So that is the reason why I am showing these things. I'm not actually going to show any code in this particular discussion. The reason is I primarily want to introduce what is happening in this arena right now, and I want you guys to explore it and understand it at your own comfort. I believe that you have learned a thing or two from this discussion. Do leave a like and share it with others. This video is kind of a overarching view of what is happening in large language model arena in this particular point of time. So I believe that most of your colleagues, your team members, your senior managers, or if you are a leader by yourself, then you have to understand these things. And do share it with others. With that said, do subscribe to my channel for further updates on similar kind of videos. As I always say, it's not just I work with large language models. I cover various other aspects of open source ecosystem in Python, and I try to provide different kinds of insight which helps you to understand the overuse that you saw here. Like in this case, what GPTQ exactly is, who are working on GPTQ right now, and what kind of languages, what kind of teams are working on it, what was there before GPTQ, and is there something which is actually bringing it all together, like Oobabooga, text generation UI, and how to work with text generation UI. So I believe that you will have some questions and you would like to discuss more about it. Do leave a comment in the comment section. With that said, I would like to leave you to think and practice, and see you guys with the next video. Till then, always I leave with 4 words, that is explore, 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 explore. See you guys. Great time.